We now have seen how we can check the input parameters to the time class. But what happens if there's more setters and getters which can all compromise the state? Let's assume we have a method advance, which takes a number of seconds by which to advance the time. For instance, a value of 3600 would advance the time forward by 1 hour, whereas a -60 would set back time by 1 minute. Here's our advance method. I skip the details of the computation right now, but instead we focus on the postcondition. We assume we do have a method, seconds since midnight, which returns the number of seconds that have elapsed in this very day. Then we can set up a postcondition, which simply says that after we advance the time, then the new seconds since midnight should be the old value plus the offset of seconds. All of this modulo the number of seconds in a day, such that we properly take care out of advances that go beyond or before midnight. The method seconds since midnight is rather straightforward to implement. It's the hours times 3600 plus the minutes times 60 plus the seconds. So again, we use a helper function to help us define our postcondition. But for all of this to work, we need to make sure that even after the complex computation, the state of the time object is still sane. That is, minutes, hours, and seconds are still within the right ranges, no matter what happens in this complex computation. And this is not checked at this point. What we need here is a property that always holds. In computer science parlance, we call such a thing an invariant. An invariant is a condition that always holds for some data object. What does always mean? Always means, from the perspective of a user of that object, that is at the beginning and at the end of each public method. While the method is executing, invariants can and frequently must be violated, but when the method is done, invariant should hold again. For our time object, the invariant condition is already encoded here in the argument checker, in the precondition of the initializer. But now we want to check this condition over and over again, at the end and at the beginning of each public method. What we do is we write an invariant checker. This invariant checker, called Checkrep here, checks whether the internal representation is sane or correct. In our case, we simply set up 3 assertions to check whether hours, minutes, and seconds are within the right ranges. Once we do have such a checker, we can now use this in all functions at the beginning or at the end as appropriate. For instance, after initialization, we invoke Checkrep and then make sure whether the internal state is within the right ranges. This is also true for setters like advance. Before we change something, we check whether the invariant is satisfied. And we do the same after the computation, such that if the computation in some way messes up hours, minutes, or seconds, then Checkrep will immediately find this.